square, so hopefully you saw that. There's a larger square, so this square is side 3. See, this one is a square of side 3. This one is a square of side 4. And remove one square of side difference 1. So you remove a square of side 2 from it. So this square is removed from it. So we have to draw a diagram for that. I think everybody got the diagram, so I'm not going to wait too long on that. So it's a 5 by 5 was the next one. Square of side 5. And if you remove a square of side 4 from it, I think we're left with this area here, something like that, a shape like that. So you removed a 4 from a 5. Okay, everybody got that diagram, so that's good. Complete the table then. The side of the larger square is 2, and the area of the remaining shape. So this is, we can link it back here to the side of the larger square 3 had the remaining shape 5. So if you found that one, side 3 here had a remaining shape 1, 2, 3, 4, 5. So if we had that, we can go, all right, what's the one for side 4? 1, 2, 3, 4, 5, 6, 7. Okay, 7. And then you do the same here. I think you get 9 if you do the one that you drew. So we have, the next one is 7, then 9, then 11. You can draw that if you want. And going back, we predict it's going to be 2. Okay? From then on, we can find an expression for m, the area. So this, find a formula for this pattern here, knowing this. Okay? So you could do this 2 ways. You can do this from what we did in year 7, which is kind of, okay, what's the jump here? The jump is plus 2 each time. Okay, if we add 2 each time, then there's going to be multiplying by 2 in the formula. So that's going to be 2n. So remember, repeated addition is multiplication. That's 2 times n. But of course, 2 times 6 is not 11. 2 times 5 is not 9. 2 times 4 is not 7. We're 1 too many each time, so you can just subtract 1. That's one way of getting the formula. I think the other way of getting the formula is a little bit more interesting. If we go back to the start, how do you get the area of a shape in general? If this is, let's say, well, that's 5 times 5, so that's 5 squared, the area of that shape. And what's the area of this shape? This would be minus 4 times 4. So 5 times 5 is 25, minus 4 times 4 is 16. And that gives 9. Now that is the answer that we got over here on the other side. That is 9. But what happens if we want to formalize this? If we want to formalize this, well, let's say that this is n, as it says in this. This is n, the larger side. Okay, if this is n, so it's then n squared, take away what? Well, it's 1 less than n. So it's n minus 1 squared. So you could have done this same formula with quadratics. Watch how this works out. We got n squared, and if I work out this, we know how to square brackets. N squared minus 2n plus 1. Hopefully you've followed that. That's n minus 1 squared. And then if I subtract this bracket, and remember when we subtract a bracket, everything will change sign. So we get n squared minus n squared plus 2n minus plus 1, which is minus 1. Now these n squares cancel out, and we're just left with 2n plus 1. Or 2n minus 1. It's the same thing we could get. But you could have got it just with a linear sequence. The reason I did that is because when you come to the formula at the end, it's easier to do it if you notice that at the start. Okay, so the area of the remaining shape is 381. So you have a 381 here, which doesn't follow a pattern. We want to know what the side of the larger square was. So we have this formula now, we can do this. So we know the answer is 381. We have this formula, 2n minus 1. Will get us, so if I add 1 to this side, I get 382 is 2 n's. And then I can divide by 2 to get 191, I think was the answer. 191 was my answer here. Okay? All right, so let's move along to the next page. So things start to get a little bit more complicated on question 2, maybe. They draw a new shape. So this is 4, side 4. This square is side 4. And now we're subtracting 1, 2 less. So this is a side 2 square we're subtracting from it. And they counted up these boxes for us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 boxes, and that's why that is 12 here. You okay, Timon? Okay, so what do we need to do? It says you can complete this table. You may use the grid below to draw another shape to help. So what happens if we have a side 5, like we had in the previous question? So if I draw a 5 by 5, you didn't have to do this. If I draw a 5 by 5, I'm subtracting 1, 2 less than that. So if this is a 5, then I subtract a 3. That's what it's saying. So I need to draw a 3 by 3 in here, and we end up with this kind of same double kind of square boxes here. So I just count these up, and I think if you count them, you get 16 boxes. You can do another one, maybe draw the one with a 3 side if you want, a 3 by 3, and 2 less than that is a 1 by 1. So 3 and 1, many boxes here, you could add these up, and I think you get 8. And I think you notice that there may be an addition of 4 here. And there was a hint here as well in the formula at the end. It says you must use 4n in the formula. 4 times something. So 4n in the formula. Okay, what do we need? So 4 times 6 is 24, not 20. 4 times 5 is 20, not 16. So I got to subtract 4 from this for the formula to work. So this is all we needed, just a minus 4 here, or somewhere written this 4. Some people use the 4x, which is technically not correct, but you had the correct formula. It wanted to use n, so this is correct then. Which could have been done as well using my alternate method, which means this is some side of square n, so n squared would be the area of that. Take away some 2 less than n, so that's n minus 2 squared. So if I subtract these two, I can once again multiply out this bracket. N squared minus 4n plus 4 is this multiplied out, which we should know. You okay, Anzio? So then we subtract everything. We get the n squares are going to end up cancelling. Make sure to change the sign inside here when I apply the minus in. That goes away, and we have 4n minus 4, which we get the same way. So there's 2 ways of getting it. Okay, let's move on to the last page. Then it kind of, you see the scaffolding starts to disappear. We get less and less help every single time, so it gets more and more difficult. Use your table to complete from 1C and 2B. So in 1C, which is on the first page, 1C, thanks Winston, 2n minus 1 was our formula, and 2B, 4n minus 4 was the formula. Okay? This is the answer for this, 2n minus 1. So when the side difference between the two is 1, that was our formula. When the side difference between the two squares was 2, this was our formula. Now you could have started to draw these again and figured this out a different way, but they wanted you to do this. Okay, what's the next one? Okay, we're going to do this 2 ways again. Just look at the patterns here. We got 2n, 4n. I'm seeing 6n and 8n. And I got 1 and 4, and then what the next one's going to be. This is a bit trickier because these are square numbers, 1, 4, 9, and 16. So we're looking at square numbers. This would be a lot easier if you did, like I did in the first question, n squared minus n minus 1 squared gives this answer. N squared and n minus 2 squared gives this answer. And n squared, n minus 3 squared gives that answer. Now you could have got this one if you drew it as well. So if we do a 5 by 5, and we go, right, the side difference now is 3. Okay, so if I have a 5, 2 would be a side difference of 3. So I draw one here, a square of 2, and I'd shade this in. And that is how I could get this, a numerical method for this. And then you could get the formula doing the same thing. Look at the numbers, and then you'll find it's 6n minus 1. You could draw another one, the 4 by 4, if you wanted a side difference of 2. Or side difference of 3 now would be 4 and 1. What's the area here? So you'd do that same table you had before, 4 and 5. You'd count up these squares. You'd find the formula, and then you'd put it in here. The formula would be adding 6 each time. Okay. So it started to get pretty tricky there. And then find an expression for n and d in terms of the remaining shape and side difference. Okay. A little bit tricky. So if you got this correct, I think this is easy. You can just look here and look at my patterns. What am I subtracting each time? if you notice the way the side difference is 1, I'm subtracting 1. The side difference is 2, I'm subtracting 4. The side difference is 3, I'm subtracting 9. Side difference is 4, I'm subtracting 16. So it looks like 4 squared, 16, 3 squared, 9, 2 squared. So I'm subtracting d squared, this is our d number. How do I form this number then? N is definitely there. How do I get 2, 4, 6, and 8? Well, that's all of these doubled. 1, 2, 3, 4 is 2, 4, 6, 8. So that's 2d times n, because n is here all along, and that is the answer to this. The other way to do it is, and I think the easier way to do it is look at this. Look at this. 1 corresponds to 1 here, 2 corresponds to 2, 3 corresponds to 3. So the difference here, that's the difference. That's all I need to sub in. So I could go n squared minus n minus d squared, and that's also the formula. These are the same thing. If you're not sure about that, I'll do just a little bit of working out on a different page. I'll just work this one out. So that's n squared minus n minus d times n minus d, which is n squared minus, I'll keep these in brackets for a second because I'm going to have to subtract them all. I think I get minus dn plus d squared here, if I did this out fully, with the FOIL multiplication or all multiplications. Add the like terms, I get minus 2dn plus d squared, and then change the signs here. We get n squared minus n squared plus 2dn minus d squared. So these cancel, and I'm left with just this, which is the same as that. Okay, so what you had to notice was the area was formed from the bigger side squared minus the smaller side squared. And in general, that's the difference was here. The difference is constantly changing, so it's d here. You can finish it then, if you want, using that formula. You have a side difference of 7, so d is 7. The area is 3, 4, 3, which is the answer to this. This is the area. So I have 3, 4, 3 is equal. So you had to get the formula right probably to do this. I put into this one because I think maybe easier. 2 times 7 times n times 7 squared. So the only unknown here is n. How do I solve this? Well, I have 49 over here. I need to add that to this side and then divide by 14. And I think, what is the answer I got earlier? I think it's 28. N is 28. If you solve this out, so you get 3, 4, 3 is equal to 14n minus 49. So it's just a linear algebraic equation we can solve. Add 49 to both sides. And then we have, what's this? Oh, 392 is 14n. So n is 392 over 14. Now, two ways of doing this. You can divide this in, or you can simplify the fraction if you want as you go. 392 over 14. Maybe, okay, I noticed 2 fits into both. So that leaves 7 here. 2 fits into this quite a number of times. What is it? It's 200 minus... Oh, we do 200 minus... 200, is it 200 minus 6? 200 minus 3? 200 minus 4, no? 194, I think. 196, is it? Yeah, 200 minus 4, yeah, I was right. We're doing it two different ways, yeah. Okay, and then, okay, 7 fits in. 7 fits into this how many times? 7 fits into 19 twice, with a remainder of 5, and then 56 fits in 8 times, so 28.
I got 196 over 7.
And then you didn't. Yeah, so you still got the marks. Okay, so to get marks here, to get grades, it was more of using the rubric. If you were able to get 2 of the formulas correct, you got a 5. If you were able to get all 3 formulas correct and maybe made one mistake,